Right now, beneath one of Europe's most beautiful coastlines, the ground is rising by 10 millimeters every single month. And on July 31st, 2026, it finally announced itself with the strongest earthquake this region has felt in 40 years. A magnitude 4.7 tremor tore through Pozzuoli, injuring 21 people, shutting down train lines, closing a working port, and sending residents of Naples running into the streets in the middle of the night. This wasn't a random natural disaster. This was the latest chapter in a 20-year buildup beneath a supervolcano that 500,000 people call home. And in 2026, scientists studying it have started using a word they rarely use lightly: critical. Its name is Campi Flegrei, the Phlegreian fields, and unlike the volcano most people know from this region, Mount Vesuvius, it doesn't look like a volcano at all. There's no towering peak, no obvious crater waiting to erupt. Instead, it's a 12 by 15 kilometer depression in the earth, a caldera sitting just west of Naples and stretching beneath the towns of Pozzuoli and Boccoli, and even out under the waters of the bay. Itself, people aren't living near this volcano. They're living directly on top of it, inside a system geologists rank among the most hazardous on the entire planet. That danger comes from what this land has already done. Around 39,850 years ago, Campi Flegrei produced one of the largest volcanic eruptions Europe has seen in the last 200,000 years, an event so powerful that some scientists believe its climatic fallout contributed to the decline of Neanderthal populations across the continent, though that connection is still debated. That eruption was so massive it caused the ground above the drained magma chamber to collapse, creating the caldera that exists today. Its most recent eruption was much smaller. In 1538, after weeks of shaking and swelling ground, a brand new mountain physically rose out of flat earth in front of terrified locals over the course of about a week. It's called Monte Nuovo, and it proves something important. Campi Flegrei doesn't only produce world-ending catastrophes, it's also capable of smaller, localized events. The problem right now is that nobody can say for certain which kind of scenario the current unrest is building toward, if it's building toward one at all. Here's what makes this volcano genuinely unique. It breathes. Scientists call it bradysism, ground that slowly rises and falls over years or decades as pressure shifts in the magma and hydrothermal system underneath. You can see proof of this cycle carved directly into ancient Roman ruins at Pozzuoli's waterfront, where marble columns from a 2,000-year-old market building still bear the boreholes of sea creatures several meters above current sea. Level, physical evidence that this ground sank for centuries and then rose back up. The last major episode like this happened between 1982 and 1984, when the ground rose nearly 2 meters in just 2 years, triggered tens of thousands of earthquakes, and forced the evacuation of roughly 40,000 residents. It eventually calmed down without an eruption, but it left the crust more fractured, more stressed, and geologists now believe those old scars are relevant to what's happening today. Because since 2005, the ground hasn't stopped rising. Total uplift has now passed 1.4 meters, and unlike previous decades, this episode of unrest has never fully paused. It's accelerated. In April 2024 alone, Italy's National Volcano Monitoring Agency, INGV, recorded 1,252 earthquakes in the area. By early 2026, the pace intensified further. In one single week in February, between the 23rd and March 1st, INGV logged around 70 earthquakes, the largest reaching magnitude 3.5, clustered beneath Pozzuoli and the Agnano district. The pattern since has been spikes of intense activity followed by brief calm, then another spike, an unpredictable rhythm scientists are tracking almost minute by minute. Then came that July 31st earthquake, magnitude 4.7, shallow and strong enough to be felt not just across Naples, but on the islands of Ischia and Procida out in the bay. INGV was quick to state there's no sign this specific quake is a direct precursor to an imminent eruption. But that statement itself reveals something important about how this crisis actually works. More earthquakes doesn't automatically mean an eruption is coming. It means stress is moving through the crust, and figuring out whether that stress is releasing safely or building towards something bigger is one of the hardest problems in earth science today. The city of Naples shudders. A magnitude 4.7 earthquake rips through the ground beneath Pozzuoli, the strongest tremor to hit this stretch of southern Italy in 40 years. Trains stop running. The port shuts down. 21 people are injured. Families spill out of apartment buildings into the streets, some in their pajamas, phones in hand, staring up at buildings they've lived in for decades, wondering if this is the night everything changes. Within hours, more than 30 aftershocks ripple through the same ground. And this isn't an isolated disaster. This is one earthquake in a slow-motion story that has been building for over 20 years in the caldera of one of the most dangerous volcanic systems on the planet. Its name is Campi Flegrei, the Phlegreian fields, and right now in 2026, scientists who have watched it for their entire careers are using words they don't use lightly. Acceleration, critical threshold, regime change. This is the story of what's happening beneath Naples, why it matters to nearly 1 million people living on top of it, and why the rest of the world is starting to pay very close attention. To understand why a 4.7 magnitude earthquake sent shockwaves of anxiety through an entire region, you first have to understand what Campi Flegrei actually is. Most people picture a volcano as a mountain, a cone-shaped peak with a crater at the top, like Vesuvius looming over the Bay of Naples just 20 kilometers to the east. Campi Flegrei is not that. It's the opposite. It's a caldera, a vast depression in the earth roughly 12 by 15 kilometers wide, stretching from the western edges of Naples out to the coastal towns of Pozzuoli and Boccoli, and continuing beneath the waters of the bay itself. Instead of one crater, it holds at least 24 craters, cones, and vents scattered across a landscape that looks deceptively ordinary, dotted with apartment blocks, marinas, cafes, and roads. Hundreds of thousands of people don't live near this volcano. They live inside it, on top of it, embedded in a system that geologists consider one of the most hazardous on Earth. The reason Campi Flegrei is a depression rather than a peak comes down to its history, and that history is almost unimaginably violent. Around 39,850 years ago, this region experienced what's known as the Campanian ignimbrite eruption, one of the largest volcanic events in Europe in the last 200,000 years. It ejected an estimated several hundred cubic kilometers of magma and ash into the atmosphere, an eruption so massive that some researchers have linked its climatic aftershocks to the decline of Neanderthal populations across Europe. Though that particular link remains debated among scientists, the eruption was so powerful it caused the ground above the emptied magma chamber to collapse inward, forming the caldera that exists today. About 15,000 years later, a second enormous eruption, known as the Neapolitan Yellow Tuff eruption, reshaped the region again, further defining the sunken landscape that now cradles Pozzuoli and its neighboring towns. These two eruptions are why Campi Flegrei carries the label supervolcano. It has the geological pedigree of Yellowstone and Toba, systems capable, at their most extreme, of altering climate on a global scale. But Campi Flegrei's most recent eruption, and the one people tend to reference when trying to calibrate expectations, was far smaller and far more recent. In 1538, after a period of intense ground swelling and earthquakes, a new volcanic cone burst out of the earth near the coast. Locals watched in real time as a mountain rose out of flat ground over the course of about a week. It's now called Monte Nuovo, meaning New Mountain, and it stands about 140 meters tall. That eruption reshaped the coastline, created what is now a small bay, and though it caused property destruction and some casualties, it was, by supervolcano standards, a minor event. It's proof that Campi Flegrei doesn't only produce continent-altering catastrophes, it also produces smaller, localized eruptions. The challenge for scientists today is that nobody can say with certainty which kind of event the system might be building toward now, if it's building toward one at all. Between these historic eruptions and today, Campi Flegrei has never gone fully silent. It exhibits a phenomenon that makes it almost unique among populated volcanic regions on Earth, called bradyseism, from the Greek meaning slow movement. The floor of the caldera rises and falls over years or decades, driven by shifting pressure in the hydrothermal system and the magma reservoir deep beneath it. And you can see the physical evidence of this cycle written into the ruins of ancient Rome. At the waterfront in Pozzuoli stands what's known as the Temple of Serapis, though it was actually a Roman market building, a macellum, constructed around 2,000 years ago. 3 of its marble columns still stand, and etched into their surfaces are bands of tiny holes, bore marks left by marine mollusks called lithodomus. Those markings sit several meters above the current ground level, and they are physical proof that this ground sank below sea level for a long stretch of history, allowing the columns to be colonized by sea creatures and then rose again, lifting the evidence back into the open air for tourists and scientists alike to study today. It is one of the most elegant natural records of ground movement anywhere in the world, a Roman ruin that doubles as a geological instrument. In the modern era, Campi Flegrei has gone through several notable bradyseismic episodes. There was unrest in the 1950s, again in the 1970s, and then a dramatic crisis between 1982 and 1984, when the ground beneath Pozzuoli rose by nearly 2 meters in just 2 years. That episode triggered tens of thousands of earthquakes, cracked buildings across the town, and led authorities to evacuate roughly 40,000 residents from the most affected neighborhoods. It was a genuine crisis, and it eventually subsided, without an eruption, but it left the crust of the caldera measurably weakened, more fractured, more primed for future movement. Geologists studying the system today describe these repeated episodes as cumulative. Each crisis doesn't reset the system back to zero. It leaves scars, and those scars appear to be relevant to what's happening now. Because since 2005, Campi Flegrei has entered a new phase of unrest, and unlike the earlier episodes, this one hasn't stopped. It has continued, with only minor pauses, for more than 2 decades. The ground beneath the caldera has been steadily rising, and as of the most recent measurements in 2026, the total uplift since 2005 has passed 1.4 meters. Some reports place it closer to 1.6 meters, depending on the exact reference point and measurement station used. To put that in perspective, that's more ground movement than occurred during large stretches of the dramatic 1980s crisis, only spread out, and until recently, at a slower pace. Except the pace hasn't stayed slow, it has been getting faster. The Istituto Nazionale di Geofisica e Vulcanologia, Italy's national volcano monitoring agency, known as INGV, maintains a permanent observatory dedicated entirely to this region, the Osservatorio Vesuviano, and its scientists have documented the acceleration in exhaustive detail. Earthquake counts, which used to number in the hundreds per year during quieter periods, DS have swelled into the thousands. In April of 2024 alone, INGV recorded 1,152 earthquakes in the Campi Flegrei area, the overwhelming majority too small to be felt by residents, but a clear signal of a stressed and shifting crust. By early 2026, the picture had intensified further. Between February 23rd and March 1st of 2026, INGV logged approximately 70 earthquakes in a single week, with the largest reaching magnitude 3.5, clustered beneath the towns of Pozzuoli and Agnano. The following week, activity dropped to around 47 quakes, still elevated compared to historical baselines, but a temporary reprieve. This pattern, spikes followed by partial calm, followed by new spikes, has become the defining rhythm of the crisis, and it's a pattern that makes it genuinely difficult for scientists to say with confidence what comes next. Then came July 31st, 2026. A magnitude 4.7 earthquake, the strongest recorded in the Campania region in 40 years, struck at a shallow depth beneath the caldera. Shallow earthquakes matter more than deep ones in a scenario like this, because they tend to cause more surface damage relative to their magnitude and are frequently associated with fluid or gas movement closer to the surface. The quake shut down the Cumana and Circumflegrea rail lines, closed the port of Pozzuoli, injured 21 people and ways, as felt not just across Naples but on the islands of Procida and Ischia out in the bay. NGV was quick to state that there were no signs the earthquake was a precursor to an imminent eruption, and that statement matters, because it reflects a broader truth about how volcanologists interpret this crisis. Increased seismicity does not automatically mean an eruption is coming. It means stress is being released or stress is accumulating, and figuring out which one you're witnessing in real time is one of the hardest problems in all of Earth science. Alongside the earthquakes, the ground keeps rising. As of the summer of 2026, monitoring stations have recorded an uplift rate of approximately 10 millimeters per month, a pace that, if sustained, adds up to well over 10 centimeters a year. Geochemical monitoring at the surface, particularly around the Solfatara crater and the Picciarelli fumarole field, both popular and slightly eerie, tourist stops where the ground hisses with sulfurous steam, has shown a long-term trend of rising temperatures in the hydrothermal system and a shift in the composition of the gases being released. Specifically, scientists have tracked an increasing ratio of magmatic gases, gases that originate from deep, molten material, relative to gases that come purely from groundwater heated by the system. That shift matters because it suggests that whatever is driving this unrest is at least partly connected to activity in the deeper magmatic reservoir, not solely to the shallower hydrothermal system that's been the leading hypothesis in past decades. This brings us to the reason the phrase serious turn applies to what's happening at Campi Flegrei right now, and it's not just the earthquake in July. In 2026, a team of researchers, including Davide Zaccagnino of the Southern University of Science and Technology in China and INGV, along with physicist Didier Sornet and colleagues from Italy's University of Naples Federico II, published an analysis that applied a different mathematical lens to the 20 years of uplift and seismicity data. Rather than modeling the acceleration at Campi Flegrei as simple exponential growth, meaning activity increasing at a constant relative rate, the researchers found the data fit a different pattern, something called a finite time singularity. In plain language, this means the rate of acceleration is itself accelerating. It's not just speeding up. The speeding up is speeding up. This is the same category of mathematical model that's been used in physics to describe systems approaching a structural failure point, and separately, in some economic research, to describe financial bubbles heading toward a crash. Using this model, the researchers calculated a projected critical time, a point at which the current trajectory, if it continues unchanged, would bring the system to what they describe as a mechanical threshold. Their estimate places that point somewhere between 2030 and 2034, with a central estimate frequently cited around 2033. Crucially, and this distinction really matters, the researchers were careful to clarify what that date does not mean. It is not a prediction of an eruption on a specific day. It is not even necessarily a prediction of an eruption at all. Zaccagnino himself has stated publicly that the study identifies when the system is likely to reach a breaking point, but it cannot determine what happens at that breaking point given the current data. The paper describes multiple possible outcomes when a system like this hits its threshold. It could mean a large eruption. It could mean a smaller, more localized eruptive event, similar in scale to what happened at Monte Nuovos in 1538. It could mean a major bradyseismic peak, essentially the ground reaching its maximum uplift and then beginning a long, slow retreat without any eruption at all, similar to how key 1980s crisis eventually resolved. Or it could mean some other kind of structural regime change within the crust that scientists don't yet have a clean historical analog for. The study also projected that if the current acceleration and uplift continues on its present course, the ground in parts of the caldera could reach roughly 4 meters of total rise by the early 2030s, an extraordinary number when you consider that the entire crisis has already produced world headlines at just 1.4 meters. It's worth pausing here to be clear about where the genuine scientific consensus lies and where things become more speculative, because this is a topic where sensational claims spread easily and nuance tends to get lost. What is firmly established, based on decades of instrumental monitoring by INGV and academic researchers, is that Campi, Flegrei, has been in a state of continuous accelerating unrest since 2005. That ground uplift has passed 1.4 meters, that earthquake frequency and magnitude have both trended upward, particularly from 2023 through 2026, and that geochemical signals point to increasing involvement of deep magmatic fluids. All of that is measured data, published in peer-reviewed literature and tracked in real time by public monitoring dashboards. What is more actively debated is the interpretation of where this trend leads. The finite time singularity model in its 2030 to 2034 critical window is a serious, peer-reviewed piece of research, but it is also a relatively new mathematical approach being applied to a famously unpredictable natural system. And other volcanologists have pointed out that Campi Flegrei's history includes past episodes of significant unrest, like the 1980s, that ultimately subsided without producing an eruption at all. In other words, acceleration has happened before at this specific volcano and has not always culminated in the underground magma reaching the surface. The honest scientific position, held by INGV itself and most independent researchers, is that the system is genuinely more active and more closely watched than it has been in decades, that the risk profile has measurably increased, but that no instrument on Earth can currently tell you with certainty whether Campi Flegrei erupts in the next decade, in the next century, or not at all in any of our lifetimes. What has changed most concretely, and what makes this moment different from earlier decades of concern, is the response from Italian authorities. More than 500,000 people live within what the Italian government has designated the red zone, the group of 15 municipalities identified as most at risk in the event that unrest rapidly escalates toward an eruption. When you widen the boundary to include the broader yellow zone, areas that would be affected by ashfall and other secondary hazards, rather than direct lava or pyroclastic flow, the number of people living within reach of this volcanic system climbs past 1 million. That's not a remote research station monitoring an empty landscape. That's one of the densest urban corridors in Western Europe, sitting directly on top of and immediately beside an active caldera. In 2023 and 2024, in direct response to the rising seismicity and uplift, the Italian government updated its mass evacuation contingency plans for the region, refining logistics for how, in a worst-case scenario, authorities would need to move hundreds of thousands of people out of the area within a matter of days, using a mix of road, rail, and sea routes. These plans exist because the alternative, waiting until an emergency to figure out logistics for that many people, is considered unacceptable, given how quickly volcanic crises can evolve once they cross certain thresholds. INGV's monitoring network today is extraordinarily dense compared to what existed even a decade ago. GPS stations track ground deformation to within millimeters. Seismometers detect earthquakes far too small for any human to feel. Gas sampling stations at Solfatara and Pisciarelli are checked continuously for shifts in composition. Satellite radar interferometry, a technique that can measure ground movement across an entire region from orbit, adds another independent layer of verification to the ground-based instruments. This is, without exaggeration, one of the most closely watched patches of ground on the entire planet, and that intensity of observation is precisely why scientists are able to say, with confidence, that something measurable is changing, even while they remain appropriately cautious about translating that data into a specific forecast. There's also a broader context worth understanding, which is why a volcano like this matters beyond the immediate region. Campi Flegrei sits within Italy's Campanian volcanic zone, alongside Vesuvius, the volcano infamous for burying Pompeii and Herculaneum in 79 AD. The two systems are not directly connected in terms of shared plumbing, but they exist within the same tectonic setting, part of the broader subduction dynamics of the Mediterranean, where the African tectonic plate continues to push beneath the Eurasian plate, generating the magma that feeds volcanic activity across this stretch of southern Italy. Naples, remarkably, sits caught between two active volcanic hazards, Vesuvius to the east and Campi Flegrei to the west, making the greater metropolitan area one of the highest volcanic risk zones for human